Is there a food that's been dubbed the greatest trick in culinary history? That would be the crab stick, a dish with sweet, tender, and eye-catching strands of meat, yet contains no crab at all. So have you ever wondered, by what magic can humans produce over 1 million tons of crab sticks every year without catching a single crab? That journey begins in distant, icy, and endless seas, where each secret ingredient that makes up crab sticks is harvested by giant ships roaming the boundless ocean. From the refrigerated holds of these vessels, the catch is transported directly to modern factories, where every vibrant orange-red strand of crab meat is masterfully crafted to perfectly deceive both the eyes and taste buds of those who consume it. Today, join Agriculture Insight on an extraordinary adventure through the world of those familiar orange crab sticks, and uncover the secrets behind one of the most dazzling culinary illusions, where technology, creativity, and flavor collide. Let's get started. Few would guess that crab sticks, those familiar orange-red strips on sushi trays, actually began as a response to a surplus crisis. In 1960s Japan, soaring fish catches flooded the market with low-value species like pollock and threadfin bream. To save the fishing industry, Japanese food engineers invented an artificial crab meat made from surimi, minced and refined white fish. And with just a touch of red coloring to mimic crab leg meat, the world was convinced. If Japan was the birthplace of crab sticks, then the United States became the grand stage that launched them to global fame. Every year, Americans consume over 100,000 tons of crab sticks, making them a staple in more than 60% of packaged sushi trays, seafood salads, and ready-to-eat meals from New York to California. Compared to real crab sticks cost 5 to 10 times less, making them the perfect choice for anyone craving crab without breaking the bank. Though just an imitation, the value of crab sticks is anything but fake. They're convenient, easy to store, protein-rich, and ready to eat straight from the pack. And every journey has a beginning. For crab sticks, that adventure starts in the frigid Bering Sea, where ice still clings to the surface even as spring arrives and Arctic winds howl through day and night. It is here, in these harsh waters, that pollock and threadfin bream, the two primary ingredients, are harvested amid crashing waves and freezing mist, marking the start of a remarkable transformation from deep sea to dinner plate. Unlike sardines that gather near the shore or tuna that hide in the warm depths of tropical oceans, white-fleshed fish like Alaska pollock and threadfin bream swim in massive schools in the mid-water and bottom layers, at depths beyond 300 meters where sunlight no longer reaches and human eyesight becomes useless. But humans don't stop at the limits of vision. Today, fishing is no longer a game of luck, it's a battle of technology. On deck, experts monitor sonar screens and high-frequency echo sounders. When the signals appear, thick color bands drifting across the screen like clouds beneath the ocean, the captain gives the order to drop the net. The midwater trawl, a gigantic net with an opening hundreds of meters wide and as tall as a 10-story building, is released, expanding like a colossal funnel in the heart of the ocean. In just minutes, hundreds of tons of white fish, from shimmering silver pollock to pinkish threadfin bream, cascade onto the deck like a living waterfall. Their glittering scales reflect the floodlights, turning the ship's deck into a glowing burst of life in the dark sea night. But this is not an endless harvest. Every ship carries an independent observer, specialists tasked with meticulously recording every single fish brought aboard, from total catch weight to the proportion of juveniles, male to female ratio, and even the unintended bycatch. Everything is documented and sent to the Central Fisheries Management Center. Because in the modern world, fishing isn't just an industry, it's a commitment to the ocean. A long-term contract between humans and the sea, where profit, livelihood, and conservation must walk hand in hand. Break this agreement, and the price may be the disappearance of a life source that has sustained us for centuries. The moment the net is hauled up from the depths and the first fish hit the deck, the race against time begins. On modern factory ships, fish are not left piled up waiting to be processed. Instead, they are immediately rinsed with clean seawater and transferred into chilled storage holds, filled with ice at temperatures close to 0 degrees Celsius. This thick layer of ice doesn't just prevent protein breakdown, it also inhibits bacterial growth and slows oxidation, the silent threats that can ruin an entire haul in just a few hours. This cold buffer step is crucial, preserving the fish's freshness before it enters the onboard processing line. After being chilled on board with crushed ice at temperatures near 0 degrees Celsius, the fish are quickly transported to land in insulated containers, ready to enter the processing phase at the factory. Next, the fish are poured into large stainless steel washing tanks, where the cleaning process begins under strict temperature and hygiene controls. Here, high-pressure spray systems use seawater or chilled freshwater, kept below 5 degrees Celsius, to rinse off the slime, sand, fish scales, and any remaining impurities from the surface after their long journey from the ocean. The water pressure is strong enough to remove contaminants, yet gentle enough to preserve the delicate structure of the fish flesh. This step is critical in stabilizing quality from the very beginning, preventing cross-contamination and ensuring the final surimi reaches its highest level of purity. Right after the fish are thoroughly washed, they go through essential pre-processing steps, including skin removal, cutting off the head and tail, and removing all internal organs, leaving only the pure white fillet, rich in protein and low in fat, which serves as the primary ingredient for surimi production. However, even though machines handle most of the rough processing, one critical step remains that automation cannot replace: manually removing tiny bones under a backlit inspection table. Workers use specialized gloves to carefully inspect and extract each small bone by hand. This is a vital quality control step, ensuring that the raw material entering the grinding phase is as pure as possible. Next, after the fish are filleted, the white flesh is sent directly into a high-capacity grinding system, the starting point of its transformation into a standardized industrial ingredient. Here, the grinder, the core machine of the production line, operates non-stop, processing hundreds of kilograms per hour and several tons of raw material per shift. Have you ever wondered why fresh pollock or threadfin bream has a pale pink color but turns bright white after grinding? That's because this process doesn't just shred the flesh, it also continuously washes it, removing blood, oils, and fishy odors, leaving behind only the purest protein. The result is a smooth white surimi block with no smell and no flavor, ready to become crab sticks, fish cakes, and more. Each hour, the system can process 2 tons of fish, up to 40 tons per day. That means within just a few hours, fish freshly pulled from the ocean are transformed into pristine white raw material, ready to enter the global food industry. After being ground and thoroughly washed, the smooth white surimi is transferred to a mixing tank and combined with about 2 to 3% salt. Salt not only draws water out of the muscle fibers, but also helps unlock the protein structure, making the protein chains more flexible and capable of forming strong bonds. Once mixed, the surimi is precisely portioned using an automated weighing system and packed into stainless steel trays or specialized PE bags. designed to withstand low temperatures and prevent moisture absorption. This packaging process takes place in a chilled room below 10 degrees Celsius to inhibit microbial growth and prevent heat-induced protein denaturation. Immediately afterward, the packed surimi is transferred to a deep freezer at 30 degrees Celsius for rapid freezing, which stabilizes the protein structure and secures the mechanical bonds within the fish flesh. This is a technically advanced preservation step that ensures the surimi retains its moisture, avoids protein degradation, and maintains high quality until it reaches the crab stick processing plant. And this is the moment when the crab stick factory begins its work, the stage we've all been waiting for. The mixing phase is the heart of crab stick production, where smooth white surimi blocks, extracted from pollock and threadfin bream, begin their remarkable transformation. They're fed into massive industrial mixers, where hundreds of rotating paddles churn continuously in a deeply chilled environment. Here, crushed ice and brine don't just keep the temperature low, they act as protective shields, preventing protein breakdown and preserving the firm, springy texture of the fish mass. Next, vegetable oil along with supporting ingredients like egg whites, concentrated soy protein, and natural crab flavoring are added to the mixture. These components not only provide a glossy finish and subtle richness, but also act as emulsifiers, allowing water and oil to bind smoothly, resulting in the distinctive elastic and creamy texture you experience in every crab stick. The mixture is then kneaded continuously in a low-temperature environment to prevent protein denaturation. Once it reaches the ideal consistency, soft and stretchy like mochi dough, yet resilient enough to be pulled into strands without breaking, the surimi is ready for shaping. Each mixing batch can process up to 500 kilograms of material in under 15 minutes, enough to produce tens of thousands of crab sticks in a single production shift. This is the key stage that defines the eerily crab-like texture consumers around the world have come to recognize. Once the white surimi mass has been kneaded to a perfectly smooth consistency, the factory moves on to the most crucial stage, creating the iconic orange-red streaks. This colored layer is what visually tricks the eye, making crab sticks look almost indistinguishable from real crab leg meat, with delicate red strands woven through pristine white flesh. But this isn't just a matter of adding color. A small portion of the surimi is separated, ground even finer, and blended with chili powder, red yeast rice extract, and a closely guarded flavor formula. One that's been kept secret for decades. This vibrant mixture is then shaped into fine strands that become the imitation crab fibers. To achieve the perfect balance, food engineers spent decades testing and refining formulas, measuring down to the gram, adjusting ratios, and running hundreds of trials. Eventually, the industry standardized the ideal proportion. For every 100 kilograms of white surimi, around 3 to 5 kilograms of red fiber are added. It's just enough to create lifelike marbling while keeping the white meat dominant, faithfully mimicking the natural structure of real crab legs. Without that iconic orange-red streak, a crab stick simply wouldn't be a crab stick. It's this detail that transforms a processed seafood product into a masterful illusion, one that convinces millions around the world they're tasting real crab. Once the white surimi has been fully blended with oil and seasonings, the mixture moves into the extrusion system. This process isn't simply about adding color, it's about sculpting the outer layer of crab meat using precision simulation technology. The machine presses the surimi into thin, flexible sheets, uniform and smooth like edible paper, before spraying a fine layer of the signature orange hue across the surface. This forms the imitation crab leg shell. The colored surimi sheet is then rolled tightly into long cylindrical logs, with the red layer wrapped on the outside and the white interior tucked within. As these rolls move along the conveyor belt, they are gently compressed to create a fibrous texture that mimics the natural muscle strands of real crab. Thanks to this highly efficient process, the food industry now produces over 2.5 million tons of crab sticks annually, fueling sushi trays, seafood salads, and street food favorites from Tokyo to New York. After being shaped into long rolls, the crab sticks are transferred to an automated cutting system. Razor-sharp blades operate continuously at high speed, slicing each surimi stick into uniform segments with a standard length of approximately 7 to 9 centimeters. As the finished crab sticks leave the conveyor belt, they are immediately directed to the packaging area. Each stick is neatly placed into molded trays, like puzzle pieces fitting perfectly into their final frame. A transparent food-grade plastic film is then vacuum sealed tightly around each crab stick, eliminating every air bubble. This process not only preserves the moisture, but also creates a protective shield against oxidation, allowing the product to stay fresh, vibrant, and chewy as if just freshly made. Finally, the trays are sealed, labeled with production and expiration dates, and marked with a QR code for full traceability. From the surimi blocks harvested in the Bering Sea to their place on supermarket shelves, every detail is transparent and verifiable. This is the final step in transforming ground fish into a globally distributed product. Clean, compact, and ready to star in everything from premium sushi to everyday lunchboxes. If China is considered the scallop processing factory of the world, responsible for over 80% of global exports, then the United States is undoubtedly the most vibrant consumer market, where scallops are hailed as the stars of the seafood table, often fetching premium prices. Unlike other mollusks that passively await their fate, scallops are rare aquatic rebels. They snap their shells to jet across the ocean floor like tiny rockets. Along the edge of their shells, nearly 200 eyes act as a biological radar system, constantly scanning for danger and triggering escape in the blink of an eye. Here's a surprising truth. Scallops, the butter of the ocean that gourmets around the world adore, are often the target of elaborate food fraud. From young shark meat to molded surimi paste, countless imposters can be shaped into what looks like a flawless scallop. But no counterfeit can fool a refined palate. The texture turns mushy, the flavor is bland, and that signature sweetness and aroma are nowhere to be found. Just one bite, and any seasoned diner will know they've just been tricked out of a real taste experience. And every journey has a beginning. Join me as we travel back to the cold, pristine seas, where millions of scallops quietly begin their lives, destined one day to become the highlight of gourmet seafood feasts. The most common method of scallop farming today is the long line suspension technique. Juvenile scallops are attached to long ropes and left to float freely in the clear, open waters. At depths of around 15 meters, hundreds of scallop lines sway gently with the current, forming a vast and untouched underwater farm. For nearly a year, each scallop grows silently in the frigid ocean, absorbing nutrients carried by the currents. No filtration tanks, no metal cages, just the harshness of nature itself, shaping sweet, firm, umami-rich meat, one layer at a time. Scallops aren't only suspended in open water, they're also farmed using the bottom seeding method, where juveniles are released directly onto the soft seabed. This technique requires less labor but comes with higher risks. Predators and shifting sediments can threaten the growing scallops. Each farming method has its own strengths and drawbacks, resulting in subtle differences in flavor and texture across scallop varieties. Longline harvesting marks the most rewarding moment of the entire farming cycle. As the hydraulic crane begins hoisting each rope, stretching dozens of meters from the sea, thousands of tightly clustered scallops emerge, clinging like strands of raw ocean pearls, glistening, vibrant, and rich with the taste of the sea. Each heavy, rope-laden haul is the culmination of nearly a year of growth amid waves and frigid ocean currents. If longline harvesting is a dazzling performance of living pearl strands suspended in crystal-clear waters, then bottom-seated scallop harvesting is a quiet yet spectacular act of digging gems from the mud. Specialized vessels lower metal dredges, equipped with toothed bars and wheels, to the seabed, then slowly drag them across carefully surveyed terrain. Each gentle sweep lifts the soft sediment layer, revealing scallops hidden below, clinging firmly to the ocean floor. Harvest season typically runs from November to March, when the sea reaches ideal cold temperatures that enhance the scallop's sweetness and firm texture. Each dredging operation lasts only 15 to 30 minutes to minimize impact on the delicate benthic environment. On average, a single haul yields between 500 and 700 kilograms of scallops, depending on sediment thickness and population density. It's an art form, not as forceful as king crab hunting, nor as frantic as anchovy fishing, but slow, steady, and almost meditative, like hand-harvesting rice from the depths of the sea. As soon as the dredges and long lines are hauled aboard, thousands of shimmering scallops crowd together in heavy mesh bags. But the journey doesn't end there. On deck, fishermen begin removing the scallops by hand, a process that must be swift yet delicate to avoid cracking the fragile shells. The scallops are then poured into clean seawater troughs for a quick rinse, washing away any remaining sand, silt, or debris from their journey up from the depths. Each batch is scooped out, weighed manually on site, and transferred into specialized plastic containers, clearly labeled with trip details, harvest area, and date. From the deck, these fresh scallops are lifted by crane directly onto refrigerated trucks waiting at the dock. Within hours, they're en route to processing facilities, where a state-of-the-art system begins, preparing these pearls of the sea to grace dining tables around the globe. The scallop cleaning process in factories requires far greater precision than with other mollusks. Due to their deeply ridged shells that easily trap debris, scallops are passed through a high-pressure spray system, reaching up to 5 to 6 bar, strong enough to dislodge embedded sand and silt, yet finely tuned to avoid cracking the shells or harming the live scallops. Unlike oysters or mussels with thick, robust shells, scallops are more delicate and prone to damage, making every second of water pressure a calculated balance. This stage is both a science and an art, ensuring absolute cleanliness while preserving the scallop's freshness and structural integrity. After being thoroughly cleaned, scallops move on to the shelling stage, where precision and speed must work hand in hand to preserve the delicate, sweet meat inside. This is one of the most critical manual steps, requiring human skill that surpasses even machinery. Unlike oysters or clams, which need to be briefly boiled to open, scallops have relatively weak adductor muscles. This allows workers to open them alive using specialized knives, a method that retains freshness while quickly separating the prized white adductor muscle from the viscera and membranes. In many Japanese processing plants, trained technicians can open up to 1,200 to 1,500 scallops per hour, achieving both speed and aesthetic precision. Live shelling preserves the scallop's natural flavor and intact texture, a crucial requirement for premium export markets like the US and Europe. This isn't just processing, it's the art of carving pearls inside the factory. Yet despite its elegance, the task carries risks. Hard shells, sharp blades, and slippery hands mean that even a small mistake can cause injury. That's why workers must wear full protective gear and operate with extreme care at all times. In modern processing facilities, the shelling of scallops is now supported by automated machinery, easing the burden on workers while maintaining both speed and precision. Workers simply place each scallop onto a conveyor belt. The rest is handled almost entirely by the machine. A mechanical arm holds the shell firmly in place while a thin blade glides along the edge, swiftly splitting it open. The white adductor muscle, known as the scallop meat, is then neatly extracted, while the shells and viscera are separated into designated trays. On average, such a line can process between 8,000 and 10,000 scallops per hour, with an exceptionally low error rate. Compared to manual methods, this system delivers more consistent results, improved hygiene, and is perfectly suited for the stringent standards of export markets. After shelling, the ivory white scallop adductor muscles, the most prized part, move on to a final cleaning stage. A gentle high-pressure spray system, combined with aerated water baths, removes any remaining impurities such as shell fragments, membrane strands, or fine sediment. Even after careful processing, tens of thousands of scallops are inspected and meticulously rinsed every hour to ensure each piece meets an almost immaculate level of cleanliness. This step is also what elevates the product to sashimi grade, fresh and clean enough to be consumed raw immediately after thawing. In the scallop processing industry, cleanliness is more than just a standard. It's a matter of pride, of quality, and the key to preserving the highest market value on the global stage. Once cleaned and sorted, fresh scallops are packed directly into specialized plastic containers under chilled conditions. Workers, equipped with protective clothing and sterile gloves, carefully arrange each scallop to preserve its freshness and avoid damage. The containers are then sealed, labeled with traceability information, and stored at 0 to 4 degrees Celsius, ready to be delivered to restaurants, supermarkets, or processing facilities within a short time. This method is commonly used for packaging fresh scallops intended for local markets or short-distance transport. After being thoroughly cleaned and inspected, the ivory white scallop adductor muscles are fed into an automated sorting system, where each piece is evaluated based on size, color, and meat quality. Only those meeting the highest standards proceed to one of the most critical stages in the processing chain: ultra-fast freezing. In this stage, the temperature is rapidly lowered to 40 degrees Celsius within just a few minutes. This sudden freezing process locks in the scallop's original freshness, preserves its firm texture, natural flavor, and nutritional content. At the same time, it forms ultra-fine ice crystals, minimizing tissue damage and preventing moisture loss during thawing, a key requirement for sashimi-grade products. Immediately after freezing, the scallops are transferred to the sorting and packaging system. Here, each piece is automatically scanned and classified by size or weight with high precision. Qualified meats are then portioned by electronic scales, packed into vacuum-sealed pouches or trays, and labeled with full traceability information. After being removed from the shell and cleaned, the adductor muscles are briefly blanched in hot water to eliminate any odor, kill bacteria, and retain the necessary firmness. This crucial step helps the scallop meat maintain its beautiful color and structure before entering the drying process. Next, the ivory white scallop meat is either sun-dried naturally or heat-dried in a controlled environment. This process can last from several days to a week, depending on weather conditions and the thickness of the meat. During this time, moisture gradually evaporates, causing the scallop meat to shrink into cylindrical shapes, turn a golden brown color, and emit a rich, distinctive aroma typical of high-quality dried seafood. Once the ideal level of dryness is achieved, the scallops are sorted, packaged, and stored carefully. The final product retains a deep sweetness, high umami, and is a premium ingredient in dishes like porridge, soups, or gourmet seafood broths. If Portugal is the sardine factory of the world, where shimmering silver shoals are harvested processed, and exported to over 45 countries under renowned brands like Ramirez and Nuri. Then the United States is the bottomless consumer machine, spending over $50 million annually to import sardines and integrate them into every corner of fast food culture, from convenient sandwich slices to refreshing, nutrient-packed salads. Compared to canned tuna, sardines are not only 30 to 50% cheaper, but they also offer a range of superior benefits. Higher omega-3 content, rich in calcium since the bones are edible, and a more ocean-friendly profile thanks to their sustainable harvesting practices. Sardines aren't just nutrient-rich, they once sparked an economic miracle in the heart of America. In 1903, as Monterey, California was drowning in a deep economic crisis, sardines arrived en masse like a wave of salvation. In a matter of years, this humble fish fueled a booming canning industry, created thousands of jobs, and transformed a fading seaside town into the sardine capital of the world. Every journey has its beginning. Join me as we set sail for the fishing grounds of the Atlantic Ocean, where the night sky bursts into light under powerful floodlamps, and specialized fleets kick off the sardine hunt, chasing a tiny fish that brings to life some of the most breathtaking dances beneath the sea. The sardine harvesting season stretches from late spring to early autumn, when coastal waters begin to warm and shimmering silver shoals gather in massive waves. Unlike tuna, which must be caught one by one on a line, or mackerel, which require traditional drift nets, sardines are harvested using a method as strange as it is spectacular: light trapping. At night, these specialized vessels switch on dozens of high-intensity lights, transforming the sea's surface into a stage lit by artificial suns. The glow triggers the sardines' predatory instincts, drawing them to the surface as if hypnotized. And by day, enormous purse-seine nets lie in wait beneath the sun, ready to silently encircle the glistening silver shoals in an instant. No hooks, no chase, just perfect timing. Although sardines are small, they move in massive schools, sometimes weighing hundreds of tons, making their capture a task that requires advanced technology. On modern fishing vessels, radar and sonar systems are used to scan vast areas of ocean and accurately detect the movement of sardine schools swimming deep beneath the surface. Once the equipment identifies the distinctive flow of sardines, the captain swiftly maneuvers the vessel into position, while the crew gets ready to deploy a purse-seine net. The net is cast around the school of fish, then drawn tight at the bottom with a cable, like cinching the mouth of a bag, trapping the entire school in an instant. After being hauled aboard, the sardines are quickly transferred into large ice bins or deep freeze holds at -20 degrees Celsius to 25 degrees Celsius to preserve their freshness throughout the long journey at sea. As soon as the vessel docks, the catch is sent through a grading machine to separate the fish by size. They are then packed into sealed, insulated containers with ice inside. These containers are immediately transported to canning factories, ready for the next stage in a fully closed-loop processing system. Upon arrival at the factory, the sardines are transferred into large brine tanks. Workers carefully sprinkle coarse salt over each layer of fish to ensure even absorption. The sardines are left to soak in the brine for 2 to 6 hours, which helps firm up the flesh, enhance the flavor, and preserve the natural taste of the sea. After brining, the fish are poured into large holding containers, from which they are conveyed onto an automated conveyor belt to begin the cleaning process. As the belt moves forward, high-pressure water jets, delivering up to 50 liters per minute, spray cold water directly onto the fish. This powerful stream thoroughly washes away any excess salt, sand, or impurities clinging to the fish, ensuring they are perfectly clean and ready for the next steps. Once cleaned, the sardines enter an automated sorting system, a critical stage often referred to as the strategic routing station of the entire processing line. Here, rotating discs with diameters ranging from 5 to 10 centimeters act like giant sieves, sorting the fish by size, Smaller ones gently drop to the lower conveyor for secondary processing, while larger ones continue along the main line, destined to become premium canned products. With a throughput of up to 5 tons per hour, this system not only ensures fast and accurate sorting, but also guarantees that each finished can of sardines meets the highest standards of uniformity and quality. Once the sorting stage is complete, each sardine seems to have found its rightful place, gliding smoothly along the conveyor belt toward the pre-processing area. Unlike tuna or salmon, with their large bodies and thick flesh, sardines are smaller, more delicate, and prone to damage if mishandled. Their fine bones, thin skin, and high natural oil content make them particularly susceptible to spoilage and flavor loss if not processed properly. That's why pre-processing is not just a preparatory step. It is the critical dividing line between a perfect can of sardines and a failed product. In the pre-processing zone, workers wearing thin gloves swiftly remove the heads and guts of each fish while inspecting them visually and by smell. Spoiled sardines typically give off a slightly sour or sharply fishy odor. Thanks to their experience and sharp senses, each worker can handle over 1,000 sardines per hour, while maintaining the fish's intact appearance. After cleaning, the sardines are carefully arranged in stainless steel baskets, specially designed with small drainage holes to allow water to escape quickly without bruising the fish. Each sardine is placed neatly by hand to preserve its shape and freshness before moving on to the next stage. Once the baskets are full, an automated conveyor system carries them to the final rinsing area. Here, cold water sprays at high pressure form gentle streams that envelop each fish, washing away any remaining impurities while preserving their shiny skin and delicate structure. While manual pre-processing ensures precision and flexibility, in large-scale factories, technology takes the lead role. Automated cutting systems equipped with smart sensors can detect the size and position of each fish, trimming off unwanted parts in just seconds. As a result, these machines can process between 5,000 and 7,000 sardines per hour, significantly boosting overall production efficiency. After being thoroughly cleaned and neatly arranged, the gleaming sardines are placed into small tin cans on an automated conveyor belt by skilled workers. With swift and precise hands, they carefully position each fish to ensure uniform quantity and size in every can. Each worker can complete 30 to 40 cans per minute, maintaining a seamless and synchronized production line. In addition to manual canning, some modern factories are equipped with automated canning systems to increase productivity and ensure product consistency. These machines can place sardines into cans quickly and accurately, reducing processing time while maintaining quality. With the support of technology, the canning process becomes more efficient and ready for the next stages. To enhance flavor and create a distinctive touch for each product, workers add natural ingredients to every can. A few thin slices of carrot, a couple of bay leaves, or a hint of green peppercorns, all blending together to balance the rich taste of the fish with the fresh aroma of the spices. Once delicately garnished with these natural seasonings, each can is completed with the addition of water, an essential element to preserve flavor and texture during the cooking process. An automated filling machine gently pours 100 to 150 milliliters of filtered water into each can, ensuring the right moisture level for the upcoming steaming stage. Once the water and seasonings are properly balanced, the sardine cans enter the steaming stage, a crucial step that determines both quality and safety. Inside industrial steamers maintained at 230 degrees Celsius for 30 minutes, the fish is fully sterilized, ensuring long-term preservation. As small, short-lived plankton feeders, sardines accumulate virtually no mercury. This allows the process to focus entirely on maximizing freshness and flavor, a rare advantage in the world of canned fish. As soon as the freshly steamed sardine cans come out of the oven, they are allowed to cool before continuing to the next stage. Once the temperature stabilizes, the cans pass through an automated oil filling system, where about 20 to 30 milliliters of extra virgin olive oil is poured into each can, evenly coating the fish to enhance flavor and ensure rich, natural taste. Thanks to their soft, edible bones after cooking, sardines are often packed whole to preserve their full flavor and appearance in the luscious layer of oil. However, for certain premium product lines, the bones are carefully removed after steaming to offer a smoother, more refined experience for the consumer. Finally, the sardine cans are transferred to an automated sealing system. Each lid is vacuum sealed, removing all air inside, helping to preserve the freshness and distinctive flavor of the fish over time. After sealing, the cans pass through a clean water bath at approximately 4 degrees Celsius, cold enough to wash off any remaining olive oil without affecting the can's integrity. This rinsing process lasts about 2 to 3 minutes. Once clean, workers gently dry each can with soft cloths to ensure they are spotless and oil-free. Next, the sardine cans enter a high-pressure steam sterilization chamber, where they are treated at temperatures up to 248 degrees Fahrenheit, around 120 degrees Celsius, for approximately 30 minutes. This step eliminates any remaining bacteria while preserving the fish's natural flavor. Finally, the cans move to the packaging line, where they are carefully packed into cardboard boxes, typically 24 cans per box, depending on can size. Once packed, the boxes are transferred to a cold storage facility maintained at around 32 degrees Fahrenheit and Celsius, ensuring the sardines retain their freshness and flavor throughout storage.
Before we head into the modern salmon processing factories, let's uncover some fascinating secrets about these ocean warriors and their remarkable journey on fishing vessels. The starting point of their mission to bring ocean's finest delicacy to tables around the world. Let's begin in Norway, the capital of the global salmon industry. Each year, this Nordic powerhouse exports over 1 million tons of salmon, enough to produce around 5 billion pieces of sushi, making salmon a true icon of sophistication in global cuisine. Alongside Norway, Chile, Canada, and the United States are also major salmon producers, contributing to the nearly $35 billion that the salmon industry generates annually. What makes salmon truly extraordinary is their epic upstream journey. Despite living in cold ocean waters as deep as 300 meters, when spawning season arrives, salmon undertake a grueling journey, swimming thousands of miles upstream, battling fierce rapids, and evading predators to return to their birthplace, where they fulfill their life's mission of sustaining the next generation. It's not just instinct, it's a natural miracle. Here comes August, the harvest season. The icy waters of the North Atlantic come alive as hundreds of fishing boats set out to sea, cutting through the waves. Fishermen, hardened by the ocean's challenges, skillfully haul in shimmering silver catches. The triumphant sound of cheers echoes across the ocean as they conquer the waves and bring home the ocean's treasure. When the radar detects a school of salmon swimming beneath a deep blue surface, the crew springs into action. A massive net is deployed in a circular formation, gradually tightening into a giant underwater pouch that surrounds the salmon. As the net is slowly pulled up, the sunlight reflects off the shimmering silver scales of the salmon, a satisfying reward for a successful trip to sea. As soon as the salmon are hauled onto the deck, they are immediately transferred to chilled water tanks to preserve their freshness and firm texture. The cold water helps maintain the quality of the fish before they are transported to processing plants. Once they leave the ocean, these silver treasures continue their journey to cutting-edge processing facilities. At the factory, the salmon are immediately loaded onto an automated conveyor belt, where they are neatly arranged before passing through the automatic head-cutting machine. With razor-sharp blades and advanced sensor systems, the machine can process up to 3,600 fish per hour, cutting off the heads with remarkable precision without damaging the delicate flesh. Next, the salmon are sent to the cleaning machine. High-pressure water jets, combined with soft rollers and rotating brushes, wash away all the slime, blood, and bacteria on the fish's skin, ensuring that the salmon meet the highest hygiene standards. After the initial cleaning, the fish are transferred to the trimming and splitting machine. This advanced machine precisely trims the dorsal and belly fins, while simultaneously splitting the fish into two perfect halves along the backbone. The backbone and tail are removed in the same step, thanks to the machine's sharp blades and smart sensor system. With a capacity of 3,000 fish per hour, this powerhouse of a machine speeds up the processing time by tens of times compared to traditional manual methods. Even though machines handle most of the work, human hands still play a crucial role in perfecting the final product. After trimming and cleaning, skilled workers carefully inspect each fillet. They use sharp knives to remove any excess flesh or fat that the machine may have missed, ensuring that only the most tender, vibrant red salmon meat remains. Each fillet moves to the automatic weighing and sorting system. The high-tech sensors and optical scanners detect any defects, such as bruising or imperfections in the flesh, ensuring that only top-quality fillets proceed to the next stage. The machine also sorts the fillets by size and weight, guaranteeing consistency across the final product. Next comes the deboning stage. The fillets pass through an automatic deboning machine equipped with ultra-fine needles that extract any remaining pin bones without damaging the meat's texture. After this, workers double-check each fillet by hand to ensure that not a single bone is left behind. For smoked salmon, once the bones are removed, the fillets are sent to the curing stage. A mixture of salt, sugar, and herbs is evenly sprinkled over the surface of the salmon. This curing process enhances the fish's natural flavor and improves its texture. The curing time ranges from 6 to 24 hours, depending on the thickness of the fillet and the desired taste. After curing, the salmon is transferred to the smoking chamber. There are two primary smoking methods: cold smoking and hot smoking. Cold smoking takes place at a low temperature of 25 degrees Celsius to 30 degrees Celsius, producing a delicate flavor and a smooth, silky texture. On the other hand, hot smoking is done at a higher temperature of 50 degrees Celsius to 80 degrees, creating a stronger smoky flavor and firmer texture. The smoking process can last anywhere from 4 to 24 hours, depending on the type of wood used, oak and maple being the most popular choices for their rich aroma and flavor. Once smoked, the salmon is cooled and then sliced. Each slice is cut with precision to ensure uniform thickness. The slices are then vacuum sealed to lock in freshness and flavor. Smoked salmon products are stored at a temperature of 0 degrees Celsius to 3 degrees Celsius to preserve their natural smoky taste until they reach the consumer's table. Meanwhile, for salmon fillets, once the bones are removed, the fillets are transferred to the skinning machine. The machine uses ultra-thin blades to carefully remove the skin without cutting into the meat, preserving the soft, fatty texture of the fillet. After skinning, depending on market demand, the fillets can either be packed whole or cut into smaller portions. If cut into portions, the fillets are scanned by an optical machine that measures the size and weight of each piece. The automated cutting machine then slices them with remarkable speed and precision, ensuring that each piece meets the exact size and weight standards. The blades are so sharp and fast that they can cut through a fillet in less than a second. So fast that if the fillet were alive, it wouldn't even have time to breathe before the next slice was made. The fillets are then vacuum packed, ready for export or distribution to supermarkets and restaurants. Salmon fillets are typically stored at a temperature of -1°C to 4°C in cold storage facilities to maintain their freshness and quality. This closed-loop processing system, which combines modern technology with expert craftsmanship, produces top-quality salmon fillets and smoked salmon.